Like that? So you're trying to find what 2 points have a common tangent. What 2 points have a common tangent? Let's label them A, B, and C, D. We can call this f of x as well. Great. What do we know f prime of x is? Minus 1. So therefore you know that f prime of a is equal to 4a cubed minus 4a minus 1. And you know that has to equal 4c cubed minus 4c minus 1. Why do you know that that's true? Can you speak up throughout the entirety of your sentence? Because why? They share the same tangent, so the tangent line that goes through them should have the same slope. Okay, there's one equation we know. Exactly. Doesn't what?
Because it's the points in the tangent line.
No, these are 2 different points. These are 2 different points. B could equal D, I guess, if it was a horizontal, but the point could be here and here.
You know, on the thinking that because it would be at the same
No, right? You're solving for A, B, C, and D. You need more information. What's one other relationship you know you have? You know the derivative at each of these points is the same, but you also know that what's another way to get the slope of that line? Yeah, you know that. You also know that B, you know that these things right here have to equal what? Over A minus C. That is the slope between 2 points. You know that B minus D is equal to A minus C. Exactly. Good. So how many relationships do you have right here? I see more than that. How many relationships do you see? I see 1 equation, 2 equation, and 3 equation. So you know that 1 is equal to 1. That's really not a good way to label these. I don't know. The first equation, let's call it Q, R, and Z. I don't know. You know that Q is equal to R. You know that R is equal to Z. And what else do you know? How many equations do we have? 3. So we could summarize this as follows. 4a cubed minus 4a minus 1 is equal to b minus d over a minus c. You also know that 4c cubed minus 4c minus 1 is equal to b minus d over a minus c. So you have 3 equations right now. What's a slight issue with that situation? A squared plus AC plus C squared equals 1. Okay, well how about we move forward assuming A equals C and see if we can find an answer.
But
what?
But isn't that just saying they're the same x value?
They're saying A is an x value, C is an x value. It's saying that in this relationship right here, one possible relationship that makes this true is when A equals C.
But then that is not the point of the question.
If A equals C,
it's the same point.
It's got to be the same point. So if we used A equals C,
you'd find the
one point, which doesn't answer our question, does it? Yeah. That's a great observation. Can't be true. So why? Well, let's just say it because it would be the same coordinate. That's a great observation. Thank you. Let's write that down. That's important enough. So one solution is, that's a good idea, A equals C, but that cannot be true since A and C are both what kinds of values? Good observation. And if A equals C, the point would either be the same or it wouldn't be a function. The points would either be the same or we wouldn't have a function. Okay, so which relationship do we have to use? Yeah, this one right here. Now, it doesn't. Now, can that really be factored at all nicely? What do you think? No, it can't. There's no nice factorization of that right there. If it was 2ac, could you do it? Yeah, because it'd be a squared plus, it'd be a plus c times a plus c squared. Okay, so we've simplified that. Nice. Now what? Which one do you want to work on next? We have a relationship here between a and c. We have one relationship between a and c. If we wanted to solve for a and c, what else would we need to have? Okay, if you have a relationship between x and y and you want to solve for numeric values of x and y, if you have one relationship between x and y, what else do you need? Another relationship between x and y. So we've just used the equation number 1 there. We need to use some combination of the other 4 equations in order to find a relationship between a and c. That would be one way to do this. We're still in just algebra land.
It would have to be 2 or 3.
Well, look what we have here. Let's write a map here. We have this one that relates a and b, right? We have this one that relates c and d. This one represents all of them.
So you would have to use...
And this one and the other one represents all of them. A, B, C, and D. So what are we going to have to do?
We can start by simplifying b minus 3 by 7 and subtract 3.
Oh, you want to do that?
Well, that's how you could start.
That's a good idea. I like that. So b minus d, I like that a lot. That's really cool. So what you're saying is you see these two right here? B minus d, you end up with a to the 4th minus c to the 4th, negative 2a squared minus 2c squared, negative a minus c. And that would eliminate b and d. That's really good. I like that. That's a really good. Let's see if that'll work. That's a really good idea. Good job, Carter. I like that idea. Thanks. You're gonna pay me for that idea. So I like this. This is really good. Okay, so we have b minus d. So we're going to have a to the 4th minus 2a squared minus a. That's b minus c to the 4th minus 2c squared minus c. What does that equal? B minus d. So let's go back up. Which one do you want to use? It doesn't really matter which one we use. Which one? Top number 2 or 3?
A.
Which one? 2 or 3? 2. Okay. There you go. Let's plug it into there. Let's see what we get. So we're taking our relationship that we just found from here. We just found this. And we're plugging it in right there. So what do we end up with? 4a cubed minus 4a minus 1 is equal to... I'm going to pair this a little differently. That's a to the 4th minus c to the 4th. Right? Minus 2a squared. Should I... Don't use parentheses. Should be a little easier. So we have a to the 4th minus... I'll just write it out this way and then we can group it together. Minus c to the 4th plus 2c squared. All over what? All over a minus c. Yeah, cool. Okay. Now we need to see if we can simplify this. We have one relationship right here that we've built that's relatively straightforward. We need to see if we can simplify this to actually get us. So these are 2 different relationships that relate a to c. This is good. This is going in the right direction. We need to work on the numerator, though, it seems like. Any ideas of what we could do on the numerator? Let's group things nicely and see what we can factor. Exactly. So what do we have here? We have a to the 4th minus what? C to the 4th plus... Let's do minus, yeah. Minus 2 times what? A squared minus c squared, right? So what did we just take care of there? We just took care of that, and that, and that, and then what do we have? Minus what? Minus what? All over what? Is this looking promising? When that happens, you should feel good, or you should feel good either you're going to run into a brick wall soon, or we're going to get somewhere that's actually going to help us. What can we factor the top into? That's a squared minus c squared times a squared plus c squared minus 2 times a minus c times a plus c minus a minus c all over. What's the last thing we need to factor here? Yeah, the a squared minus c squared. So we have a plus c times a minus c times a squared plus c squared minus 2a minus c times a plus c minus a minus c. That's a lot of a's and c's, huh? But why is that nice now? Yeah, we can cancel out this, and that goes away, right?
Yep.
So we have to be really careful about what we left with here. We have this equation right here. We have that equation. And what is that sucker going to equal? What's it going to equal? A plus c times plus c squared minus 2a plus c minus 1. Okay, so now let's pause for a second. One general rule of algebra: don't multiply things out unless you're absolutely sure you must. So that's the first equation we have. What was that other relationship we simplified to? Right here. That's not the image I wanted. There we go. This is the we have. Yay, exciting. So we have these two equations right here. We need to somehow combine them and actually get a value. Any ideas? Do we have to multiply the top one out? So I'll relabel. Here's our equation 1 now, and here's our equation 2. Any ideas? Do you see any way other than multiplying out the top right? I don't see any other method. I mean, do you see any clever substitutions we can make right now? Slopes for each. You need not specifically when I say slope. What do you mean? Of what? X, Z, a pony, Y. So what are we looking for each of these? We're looking for Y prime on both of these. What kind of differentiation do we need to do? Y. Why do we need to use implicit differentiation? Well, and the right one isn't a function either. They're both not functions. Yeah. You can theoretically isolate X, blah, 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 but can you isolate? Yeah, you could isolate Y. Is it going to be very fun? Not really. So can someone tell me what the derivative of the one on the left is? Plus equals 0. So let's divide by 2. So what do you end up with? Y prime is equal to negative 2x. So what does Y prime equal? Are we okay with that?
Yeah.
Okay, let's do the derivative over here. What's the derivative of x? Equals. So what does Y prime equal? 1 over what? 1 over 2y. So we have two different derivatives. Two lines are perpendicular if what is true?
They have the opposite reciprocals.
What's another way to say two numbers are opposite reciprocals of one another? Okay, so these curves, I'm sorry, I'll be more specific with my question. These curves